July 19th, 2024, we lived through the single worst technology outage of our lives. If you're in the tech profession, this truly was our space shuttle Challenger disaster moment. If you're here, you're looking to better understand the outage, probably so you can learn from it. But unfortunately, most of the explanations out there are very dense with tech jargon and hard to follow, even for many engineers, and especially for non-engineers. So in this video, I want to really cut through the jargon and help explain what happened so that we can learn from it, but more to a broader audience. And to do that, I'm going to use my favorite teaching technique that I've learned over 20 plus years as an engineer, but also as a manager and a trainer, and that is storytelling and analogy. And this may sound really strange, but I'm actually hoping by the end of this video, you'll be as disturbed as I am by the totally preventable series of screw-ups that led to this outage. So I want to introduce here what I think is one of the best analogies to use when describing complex software development topics, and that is using a garden. And I know it may sound juvenile, but I promise if you stick with me through this story, at the end, you're going to have a pretty clear understanding of what happened in fairly deep detail. And I'll connect the dots with the actual outage and the terminology, so by the end, you'll have a clear understanding. So the story starts with a restaurant owner, and she happens to run a restaurant that specializes in salads and which uses fresh ingredients from local produce. And she contracts with a particular gardener who sells her produce. The issue, though, is the gardener is trying to operate a profitable garden, but they are confronted with threats, that both internal and external threats. So there's bugs and different diseases. There's external threats like wildlife and things coming in they want to eat the food, and even actually like bad guys that want to come in and poison the food, that are just looking to disrupt the food supply and make people sick. So the gardener has to contend with all of these threats. And to do that, they've developed a couple of security measures. So one is they have sprays and things that they kind of develop internally, that they've used to protect from bugs and diseases. They've also created this perimeter security to keep the bad guys and the animals out. The issue, though, is this takes a lot of resources for the gardener away from their core skill set, which is growing nutritious, healthy, tasty, fresh produce. So what they've done is partner with what I'm calling a garden threat protection. So there's an actual company that specializes in helping gardeners protect their produce from these threats. The Garden Threat Protection Company develops a custom protectant that they can then sell to the gardeners and help so that they can protect against those threats. So the gardener's happy because they get to focus on their core business. But now what the Garden Threat Protection Company is realizing is that these threats are ever evolving. There's new diseases, new bugs. The bad guys are constantly finding new ways to get into the garden. And so they have to really stay on top of this. Every time there's a new threat, they're developing a new protectant. They have to kind of deliver to the gardener, then the gardener has to go and manually apply this protectant. And it's just too slow. So what they've developed is a system. They can develop new protectant and get it to the gardens faster. But the way that works is the company, the GTP company, they need to be able to get that protectant into the garden themselves as soon as possible. So what's happened is the gardener has granted secure access to their garden to a GTP agent. And so what they're saying is, look, anytime you develop a new protectant, I want you to come here with your agent and spray the whole garden as soon as possible so that we're not at risk as longer than we have to be. They've developed a pretty good system here, but to further complicate things, the bureaucrats have gotten wind and they're concerned about antitrust issues where the GTP company or the gardener have like sole rights over this sort of process. So what they do is they actually force all gardeners, they must allow this secure access to the GTP agent and also allow them to deliver that protectant into the garden, at will. So the Garden Owners Association has stepped in here to kind of force that access. So that has set the stage for how this process works. So what actually happened? What happened is on a Friday morning, the restaurant owner showed up to get her truck full of produce that she needs to run her restaurant. Without it, she cannot run her restaurant. She shows up, the garden is in chaos. She finally, finds a frantic garden, technician and says, "What's going on?" And he said, "We don't know, but all of our plants are wilted." And he just runs off. And so the restaurant owner is just kind of stuck, doesn't know what to do, and kind of has to go back to her restaurant and just start turning customers away. She doesn't know if it's going to be a few hours, a few days, if she's going to have to close up shop. All she knows is she can't run her business right now. So fast forward about 90 minutes, and unfortunately, the situation doesn't get better. It actually gets far, far worse, where actually what is discovered is the garden protection company developed a faulty chemical. They delivered that, and all of the GTP agents started to spray just like they always do as soon as they get the chemical. For 90 minutes, they sprayed this garden, and not just the restaurant owner's garden, but every single garden around the world at the same time. So at this point, it was pretty clear that there was a true sort of disaster at hand. And so what did they actually do to remediate the issue, to kind of get things back up and operational? So as I said, the Garden Threat Protection Company developed this faulty chemical. They also developed a cleansing agent. It was possible to go back and actually kind of bring these plants, breathe new life into them. But the issue is this faulty chemical, not only did it wilt the plants, but it damaged all the sprayers. So it couldn't just be delivered, and there really wasn't enough agents to go around anyway, but it really couldn't be delivered and applied like the cleansing agent. Unfortunately, the garden technicians, the gardeners themselves, had to go pick up this cleansing agent and then go apply it to every single plant by hand. So they had to go through and spray their entire gardens by hand and kind of hope that they, came back to life. And there was a certain procedure that they had to follow to do this. And on top of that, all these garden technicians from local areas had to come in and try to get those sprayers back online as soon as possible. So hopefully you're sticking with me and following along so far. Next, we're going to look at just what actually happened. Where were the processes that actually failed to lead up to this disaster? Obviously, there was inadequate chemical testing in the factory itself. So while they were developing this, something happened in their process that allowed this fault to occur in the first place. Even though they've developed many of these chemicals over time, something broke in their process there that they didn't catch. On top of that, it was painfully obvious that they never even attempted to spray this on a test garden. Not even sure that they had a test garden on their facility, because as soon as it was sprayed on any plant, any garden, it wilted immediately. So had they just sprayed it on a single plant before shipping it out, they would have discovered that, we have a problem here. On top of that, they decided that it was safe to deliver this chemical to all gardens around the world at the same time. So instead of, hey, we're going to roll it out to some of our trusted partner gardens, and they're going to try it out for us, and we're going to make sure that there's nothing wrong, and then we'll maybe roll it out to different states at a time. Nope, all gardens all at once. Not only that, but when the GTP agent was spraying in just a single garden, rather than spraying a little bit and waiting for a second to see if it was okay, they blindly followed procedure and just sprayed the entire garden all at once, continuously for 90 minutes, without even really observing to see what the effect was. And 90 minutes. It took 90 minutes of this going on all around the world for them to really kind of finally figure out what it was and to stop shipping that chemical and to deliver the fix for it. Another piece of it that's a little more subtle is that the garden owner, and obviously even the restaurant owner, but they really didn't have any visibility into this process. So they didn't really know, half the time they didn't know that the agent was even on site. The agent would come in, they had a secure key card access, they would come into the garden, do their thing and leave. Sometimes it was midnight, 4 a.m., 2 p.m. They came and went. And the whole process was invisible. And that was part of the benefit to them, is that they didn't have to worry about it. And they put their ultimate trust in the Garden Threat Protection Company and their processes. So they didn't have the ability to even interject if there was something that they were uncomfortable with, because it wasn't transparent to them. The sprayers were damaged. So the sprayers weren't tested with the new chemical, right? And then the GTP had access to these sprayers. They could have tested them there, but they didn't test that piece either. Therefore, it required this very manual intervention. Gardeners themselves had to go and manually spray each plant. Part of the issue was allowed to happen because through the bureaucratic process, they sort of chose a fair marketplace over security. So by forcing every garden to allow this secure access, they kind of like exacerbated the issue, allowed the issue to happen. Whereas in some locations, they actually weren't forced to do this, and they actually weren't impacted by this at all. And then to put icing on the cake, the Garden Threat Protection Company, to kind of make amends, they sent the restaurant owners and the technicians and the workers a $10 Uber Eats gift card for their troubles, which, by the way, 3/4 of them didn't work anyway because the code leaked online, and then Uber shut down the code. So let's bring this story back into reality a little bit, and I'll bring in some of the actual terms and things that were involved with the outage. So the garden, the analogy kind of falls apart a little bit, but you have to give me some creative liberties here. Crowdstrike, obviously, is the Garden Threat Protection Company. Their system that they've developed is a software that runs on the Windows kernel, which means it has secure access to the Windows operating system, all of the resources on the machine. So it's behind that secure fence. So they developed this kernel driver, and the way it works is the kernel driver runs when Windows starts up. So every time Windows starts up, this piece of software runs. And what CrowdStrike will do is they'll deliver these, they call them content files. Anytime there's a new threat detected, they've analyzed that and they develop these new content files, and they deliver those immediately to the operating system. The kernel driver reads that file and is able to now detect those new types of threats. The EU Commission is who I'm referring to. I'm not sure what commission, but in a ruling, they forced Windows to allow this type of access, this type of secure access, so that third-party developers could get kernel access, this secure access to the operating system, whereas Apple wasn't forced to do this. So that's why there wasn't an issue on MacBooks, because it just worked differently. So if we look at this issue, what actually happened, I'm going to try to run through this pretty quickly because hopefully it's already clicked. Inadequate channel file testing to begin with. So CrowdStrike, they've developed these channel files. Whatever process they have to develop that, something was broke in that process itself. As I mentioned, it's kind of painfully obvious at this point that CrowdStrike didn't locally test this. They've even sort of admitted to this in one of their incident reports, where one of their action items is to do local developer testing, which is shocking that they weren't doing this, if that's true that they weren't. But they kind of obviously didn't, because all they had to do was run this on a Windows machine, and it would have failed. So they didn't test locally. They deployed to all computers at once. This is almost the most staggering thing that I've seen here, but they delivered to every single computer all at once. There was no staggered rollout of this channel file. So that allowed the widespread nature of this defect to happen. It took 90 minutes. I'd say they still responded fairly quickly, but for a long time, given how widespread this was, taking down airlines, 911 call centers, it was really bad for a pretty long time. The actual bug, when that chemical is being sprayed itself, that person who has secure access, that kernel driver that has secure access and is running, it loads this channel file, and it's supposed to check that channel file first. Before it tries to execute it, it's supposed to check it. And there was a defect in there, and it didn't properly check it. So it just tried to run. The suspected issue is that the channel file itself was faulty, and the code that ran in the validator basically was trying to access null memory or something like that. I'm not a C++ developer, so I'm sure somebody else can give more details on that. Because the kernel driver was developed as a boot driver, that means Windows would load it on when Windows started. Windows didn't have an opportunity really to correct itself or to just kill a bad program. It had to shut down the whole operating system and reboot. So because that was happening, it was in a boot loop, there was no way CrowdStrike could remotely fix the issue. So human beings had to go to each computer, and there's pictures online of people on ladders, gaining access to these PCs they have in airport terminals and things that are screens up on the ceiling. They had to gain physical access to every single computer and manually remove that channel file. That was essentially the fix, to go in and delete the channel file, boot into safe mode, delete the channel file, restart, everything was good. As I kind of already mentioned, the company didn't really know what was going on because all of this is sort of hidden. That's part of the value that CrowdStrike provides. And the $10 Uber Eats gift card is a real thing. There was no analogy to that. I was really hoping that this wasn't what happened because, again, CrowdStrike is a respected product engineering company, but this really happened, I think. And so what a kind of a smack in the face to the people that spent their multiple days or entire weekend putting out fires. And the fact that this affected hospitals, this affected emergency response. The days to come, we are going to show that there was a real human impact to this issue. And they sent out $10 Uber Eats gift cards. So it just kind of shows a lack of true understanding of the scope and the scale of this problem. So what can we actually learn from this incident? And most engineers or people who are close to the software development process, you're going to see some very obvious issues that most likely you've actually already taken care of in your software development processes. So I'm not actually going to go through those learnings because in modern software development organizations, we have developers do local testing. We have automated pipelines where we're testing the full end-to-end capabilities of the software before shipping it out. In certain cases, depending on the risk involved, we'll do staggered rollouts just to one region or a handful of customers first, just to test out, especially if there's performance implications. So I honestly don't think that those are where the key learnings are going to come from. What I think is we're going to find over the coming months when CrowdStrike releases their full incident report, which they're going to release that publicly. And I'll read through that word for word and do the analysis on that. And two, there will be third-party investigations, possibly even governmental investigations that will happen. But I think what we're going to find, unfortunately, is, I mentioned the Challenger disaster, which is a tragic and also a fascinating story about what can happen in a company that leads to these types of issues. Somebody somewhere knew something. There were people in the organization who were not comfortable with this process. Some engineer, some product manager, some DevOps engineer, somebody was raising a red flag, and the culture itself allowed those issues either to never be raised up, or when they were raised up, they just weren't taken seriously. Now, I'm speculating on this, but I would almost guarantee that this really is more of a deep-seated cultural issue. And anytime you have a profit motive, the profit motive is almost always going to, at some point, trump quality. We're going to have quality good enough. And CrowdStrike is a for-profit company. So, and I think the other piece you have is if you look at the last 10 years, starting from 2010 through 2022 even, you had this new kind of startup mentality that became pervasive in the industry. And it was move fast and break things. there was always a new VC around the corner if this venture fails. So we had this kind of mentality in the industry, and unfortunately, I think even engineers that came up in this time weren't always coached to care as much about quality as they did about speed. And Crowdstrike was a company that came up throughout all this time. The last learning is really more of a rant, and it gets down to the kind of the core reason I even created this channel to begin with, and that is professionalism in software development. And I think that the industry has become, it's a series of feature factories, if you've heard of that term before, where really the value that an engineering organization, I'm talking about QA folks and analysts and product managers and engineers and DevOps and cloud and infrastructure and network, the people that build these systems, companies more and more seeing them as just an avenue to ship features into production. And I feel like the professionalism is something that is slowly fading from the industry, where doing things the right way and taking some time to do them right is no longer what's valued. Earlier in my career, that was what was valued. I was usually praised for my work being of high quality, and I never was the fastest. Where in more modern times, it was move fast and break things. And so I feel like that mentality has kind of pervaded a whole generation of product engineers, we'll say, kind of generally speaking. So that's it. Really appreciate your time. Do me a favor, let me know in the comments what I got wrong, because I'm sure that there's some subtlety that I missed, or maybe I misstated something. So if I did, I don't want to spread misinformation out there. Also, give it a like if you got something out of it, subscribe, all that stuff. It does really actually help small channels quite a bit. And this incident is proof that the software industry really is broken, but that doesn't mean that we have to be. Thanks so much for watching. See you in the next one.